I'm going to explain about the Doppler effect because it's the theory behind of the Doppler radar that we're going further in the next session. Okay, for this session, I'm going to explain about the Doppler effect, and Doppler effect is proposed by a physicist in 1842. The physicist's name is the Christian Doppler. And the Doppler effect is state about the difference between the observer wave with the observer frequency and the emitter frequency of the observer in any state of moving object. Okay, for the application of Doppler radar is we're going to use in the aviation, in the baseball to check the velocity of the ball, and it also be used in the healthcare to detect the fall detection. Okay, for the Doppler radar, it's a specialized radar that use Doppler effect to take the data of the velocity data of the moving object. Okay, I'm going to talk. We're going to go more further about the theory of the Doppler radar in the next session. Okay, let's go. Jom.
So I will go regarding a bit about theory, but before we go depth in the behind the formula regarding the theory, so I will go a bit introduction about the theory and regarding the Doppler radar. Okay, so first we will have to know the very basic behind radar. What is radar? Okay, what is radar and why is radar? What it does. So first of all, what is radar? Okay, radar is an acronym, stands for radio, detector, and receiver. Okay, so what it does? So like the name says, it detects and receives wave from different distance. Okay, so we on this project we're gonna use Doppler radar. So first we're gonna look what's the difference between normal detector, normal radar, and Doppler radar. Okay, normal radar, you imagine you have two things. One the transmitter and one the detector. Okay, for normal radar you have a detector and the receiver in the fixed place, in the fixed position, whereby the both of it at the same difference, transmitter and receiver. Okay, and then for the Doppler radar, the detector is in a fixed place, but the transmitter is moving and varying between the position and velocity. So that's the difference between Doppler radar and normal radar. So you have to understand a bit. So we're gonna go in depth in terms of the formula and everything. So on that session, my friend will continue. Okay, let's go.
I'm going to talk about the Doppler frequency shift and how to determine the Doppler frequency shift. So the first important formula is the wave observed, it's Fr equals to Ft plus Fd. Fr is wave observed by stationary observer, Ft is the frequency of wave radiated by moving source, and Fd is the Doppler frequency shift. So this is the first equation, and then it can be related to an electric field, or basically any form of wave equation that has a phase and a direction of propagation. So by getting the phase difference of an object that's transmitting a wave, you'll get this equation which relates it to its distance from the observer and also the time at which it's moving, also the velocity at which it's moving. And you can determine Fr, which is the frequency observed by the observer, by taking 1/2 pi multiplying by the derivative of the phase difference with respect to time. Then you'll get this equation. So by comparing this equation and the first equation, you'll finally get this equation, which is you'll get the Doppler frequency shift for a wave. So the Doppler frequency shift, right, it happens 2 times. That's why it's multiplied by 2, because it's transmitted by an object that's transmitting it, then it's reflected by the observer, by the object that's receiving it. So there's a reflection, so it happens 2 times. So finally, if you want to know the direction of this Doppler shift, you have to use this formula where it's negative of this multiplied by cos theta. It's negative because this is how they want to study it, and so when it's theta 0 to 90 means it's moving away from the object, so you get a negative Doppler shift. And then if it's from 90 to 180, you'll get a positive Doppler shift. It's moving away from the object, I mean towards the object, sorry. Yes.
My name is Josh Elmi, and I will be talking about the application of Doppler radar. So in Doppler radar, it is used widely in our daily life. In military, it is used to detect the incoming missiles and its velocity. In aviation, it is used to detect the velocity and location of the aircraft. In sport, it is used to measure the velocity of balls used. And in our land traffic control, it is used in speed trap camera to capture the speeding car. Thank you.
So, do you know the difference between ordinary radar and Doppler radar? So basically, an ordinary radar, it detects the time taken for the echo to be received back by the receiver. But a Doppler radar is different. Not only does it take the time taken for the reflected wave to go to the receiver, it also measures the shape of the wave. In particular, the phase shifting of the wave. As my friend Arvin said, negatively shifted reflected wave would be a wave that is moving away from the receiver, and a positively shifted wave would be an object that is moving towards the receiver. So basically, using this property, you can use Doppler radar to know the position and also the speed of an object.